Good afternoon, everyone. Thank you for joining us today. Today's topic is the brand new csPI ConSteel programming interface, which was introduced in the ConSteel 11 version. I am András Herbai. I'm your host today. Just for some practical information, control panel can be hid with the red arrow button. Questions or messages can be sent with the chat option. At the end of the webinar, I will answer them. As usual, this webinar is being recorded and will be posted on our website and YouTube channel. Quickly about the agenda. At first, I will shortly introduce you the csPI interface. Then I will present how can you create objects. Then I will show you the handling of variables and for loops and if-else statements. So what is csPI? csPI means ConSteel programming interface, which allows you to create great variety of parametric ConSteel model. With csPI, you can create all of the ConSteel objects, such as structural elements, beams, members, plates, etc., supports and link elements, load groups, load cases, and loads, of course, point, line, and surface load. And csPI is able to handle variables, and for repeats and branching, you can use for loops to execute the same code over and over again with different values and if-else statements. For csPI, we have created a wiki page, wiki.consteelsoftware.com, where you can find detailed description and copy and paste sample code to help learning. So let's see. So this is the wiki page, and on the bottom of the main window you can find the csPI section of the page. If you click on the csPI function documentations, you can find a lot of detailed information about all of the csPI commands with some basics and all of the commands and some downloadable model codes as a sample codes. Okay, so this was the brief introduction of csPI. Let's see how is it working. So the csPI editor can be found on the bottom of the main window of ConSteel in default in minimized sized. In minimized sized, only some main functions are available. With the folder button, previously created csPI file and code can be opened. With the arrow button, you can run the actual code. And with the double arrow button, you can minimize and maximize again the csPI editor. Okay. In maximize view, we have some extra options. We have undo redo function, but this function works just for the csPI editor. If you would like to undo a ConSteel model creation, you have to use the original undo and redo functions that you can find here. And of course, the csPI code can be saved with the save button. csPI code is saved in a separate file with .cspi extension at the end. So the code is independent from the ConSteel model file, and you can use it in any ConSteel model. csPI editor is a resizable window the top edge of the editor can be grabbed and moved and resized. And of course, the editor can be undocked, so you can move to a secondary screen if it's needed, and you can dock back again. Okay, so let's create our first csPI code. It will be a tapered column with a simple support. So the first step to load a cross-section which will be used for the member. In csPI we can load two types of cross-sections. So if you go to the wiki page, you can see we have a load section command. This command load the standard library, the sections from the standard library, and we can create macro sections into macro section command. If you see the load section commands, we can see we have only just one attribute. This is the name of the section. Let's try it. So we have to type in the editor at first the command load section, and if the command is correct, it is highlighted with yellow, and after that the name of the section. And now if you click on the run button, we got a message and operation succeeded. And if you go to the structural member tab and if you open the section administrator window, we can see the section is loaded accordingly. The second type is the macro cross-section. With the macro section command, plenty of macro section can be loaded. If you go back to the wiki page and click on the macro section command, we can see all of the type of the macro section which can be used for the macro section command. So the main two types is the welded front plates and the cold formed and rolled cross sections. So now let's load a welded I or H cross section. If you click on it, we can see all of the parameters and the simple code of these commands. So now let's load a new macro cross section. So at first we have to type the command, which is macro cross section. Now the second parameter is the ID of the section. It could be a unique ID if you would like to refer to this section later, for example. If not, we can give a simple ID for it, so it is up to you. The next parameter is the macro type name. In this case, it is welded I or age 101. All of the name of the macro cross sections can be found on the wiki. So here you can see the name, the macro type name, and of course if you go back here you can find the names for each macro cross section type. Okay. The next parameter is the name of the cross section, which will be shown in the section manager. So for example, I give a welded I, so this will be the name of the cross section, but it is also up to you. The following parameter is the material grade. So in this case I give a S 2035 EN. the material grade must be exactly the same as one of the predefined ConSteel material grade, so you can use these material grades for the cross sections. Okay, and the last parameters are the macro section specific parameters. In this case, we had to give the width of the upper flange. So now I will, so upper flange, which is 300 millimeters. The thickness of the upper flange is 16 millimeters. The height of the section is 300 millimeters again. Thickness of the web is 8 millimeter. The width of the bottom flange is 300 millimeters, and the thickness of the bottom flange is 16 millimeters again. And if you run on the play button and we were correct, operation is succeeded. And if we open the section manager, you can see the name is what was given, and all of the parameter and the material grade is accordingly to the settings. So if we see another cross sections, you can see what are the actual parameters. So here you can see, for example, a macro section code, and you can use this sample code also to try how can you load a new macro cross section in csPI. Okay, so let's go back to our simple code. If we have loaded a section, we can create a member. All of the objects can be created with the create command in csPI. So if you go back to the wiki page, here you can find the create command, and here you can find all of the object types which can be created by the create command. So if you would like to create a column, we have to use the create command and the structural member. So the column is a structural member. If you click on it, we can see the syntax of the create command and all of the parameters. Okay, so let's type create. The next parameter is the ID again of the object. So it will be, for example, a column ID, but it's up to you again. The next parameter is the object type. So now it is structural member. Structural member. And the last command parameter is the section, which will be the loaded well-designed section, and we have to give the section name. It was the well-did I section. Okay, so this is the command line, and every object has some unique object parameters. Also, parameter can be required or optional. So if you go back to the wiki page, you can see, for example, in case of structural member, you can find object attributes, and in the second column you can find the parameter is required or optional. So you can find all of the parameters that can be used in case of structural member object. So the first required parameter is the coordinate of the start point. Now I would like to place in the global origin, so that's why I type 0, 0, 0. It is the coordinate in the x, y, and z direction. The next required parameter is the endpoint, so it will be a column, so that's why x and y is 0, 0 again, but the z is 3000. So with this parameter, the column will be created with 3000 millimeter height. Okay, we can add some optional parameter, for example, the release, the end release. At the start point, for example, it will be continuous at the start point. And could be pinned at the start point. And everything is correct. And oh, there is a mistype. Okay, now it's correct. Yes, but there is another mistype. So it will, so the ping end release will be at the endpoint of the column. Okay, so now it's correct. So here you can see the section is valid I, the previously created macro section. It is continuous at the start point, and it is pinned and the endpoint of the column. But if it's needed, we can give some extra parameters, for example, eccentricity or rotation for the column. Eccentricity in y direction in the local coordinate system of the column. So I will move the column with 200 millimeters in the plus y direction in the local coordinate system of the column. And the z direction 500 millimeters, and we can also apply some rotation. And if you run again the code, you can see that the column is moved accordingly and rotated. All of the extra attributes or optional attributes can be found in case of every object in the wiki page. Okay, so the column is ready, but I would like to create a tapered column. So if you would like to use or create a tapered member, we have to again use the create command. Create. So the first option, first parameter again an ID. So for example, it is tapered ID. The next parameter is the object type, so it is tapered member. The next parameter is the ID of the member on which the tapering should be placed. So it will be, so we have to give the ID. It will be the column. And the last two command parameter is the height of the taper member at the start point and the end point. For example, at the start point is 400 millimeter, and the end point it will be 1000 millimeter, and we have one extra object parameter, and this will be the placement of the taper member. So the taper member could be, sorry. So the taper member can be placed in centric, or the bottom, or on the top. So now I'm placed on the top, and if you run again the code, you can see the taper member is created accordingly, and if we select it and we see, if you see in the property area, the tapered object is created with the given parameter. So the initial height at the start point of the member is 400 millimeter endpoint, and at the end point it is 100 millimeter, and the format is upper. Okay. And if we have a structural member, we can give or we can create a point support also on the bottom of the column. Point support can be created with the create command again. So let's type create. The first parameter again an ID, for example support ID, but it is up to you. The next parameter is the type of the object name. It is support point. The next parameter is the ID of the member on which the support should be placed. So it is the column again. So we have to type the ID of the column. The last common parameter is the type of the support, for example. So we have to use one of the previously created support type of ConSteel. For example, it is pinned and fixed around the Z direction. Okay, and the last parameter is object parameter, which is the coordinates of the support, and because we would like to place on the bottom of the column, we have to give or type the start point coordinates of the column. So that's why it is 0, 0, 0 again. And if you run again the code, you can see the column is created, and the proper support is placed on the at the bottom of the column. Okay, so we have a simple code which is create a simple tapered member with a support. But this code is not parameterized. So now let's see how can we make a parametric model from this simple code. So for this, I will have to show you how can we handle the variables. But before I do it, I would like to show a small tip and tricks in csPI. In csPI, we can use comments, of course, which make the code more transparent and informative. Comments start with double slashes. So for example, double slash, and this will be, for example, this part of the code is the model building. And let's start the code with the input datas. Inputs, for example. And now I start to type or add some variables. For example, the first variable will be the origin of the column. So, and now we can start, we can add the variables. The variables start with a dollar symbol. So that's why if we would like to create a new variables, we have to start with a dollar symbol. So for example, after the dollar, we have to give a name. So this will be the coordinates of the origin in the x direction. So it is 0 now. In the y direction, it is 0 again. Cool. Let's add variables for the height of the column. So this will be the H0 and the value is 3000 millimeters now. And we can add some parameters for the macro section also. For example, the width, the first variables will be the width of the flanges. It's 300 millimeters. Thickness of the flanges is 16 millimeters. Height of the section is 400 millimeters. And the last parameters of the section, or the last variables of the section, is the thickness of the web, which is 8 millimeters. And also we can add some variables for the tapered members. So I will add new variables for the height of the tapered member at the start point. So it is 400 millimeters now, for example, and also the endpoint. At the endpoint it is 1000 millimeters. These variables can be used in the commands. So let's go to the commands and change the values in the commands for these variables. So let's start with the macro sections. So we can use these variables in the macro section commands. So I modify the commands accordingly. So now the width of the flanges and the thickness of the flanges will be same. Okay. Next parameter is the coordinate of the member and also the support in the x direction and also the y direction. We have parameters for the height of the column also. And for the tapered members, the start point height and the end point height. Of course, so it's correct. And if you run again the code, you can see it is created accordingly. And now if you modified some of the parameters, the code will be executed accordingly. So for example, I'm modifying the height of the column, or I'm modifying the tapered parameters, and run again. You can see the code is executed accordingly. Okay. But into variables we can put not just value, but expression also. So let's make the tapered member end height depends on the thickness of the top flange of the cross section. So for example, now I go to the variable of the height of the tapered member at the endpoint by modifying the values, the variables. So now the tapered member will be 1000 millimeter and plus, for example, 2 times thickness of the top, thickness of the flange. And if you run again the code, you can see the end height is not 1000 millimeter, but 1032 millimeters. And if we modify the parameter and run again the code, you can see it is 1040 millimeters. Okay. We can use for loop to execute a block of code, a number of tiles. So for example, I would like to create not just one but several number of columns with a specified distance between each other. For this we have to define some extra variables. So for example, the number of the column, how many columns I would like to create it. So for example 5, and the distance between the column. It will be the D variable, and let's start with 3000 millimeter. Okay. And I define some auxiliary variables which will be modified through the code run. So I add some extra variables, the origin of the column. So in default it is equal with the initial origin, but these variables will be modified through the code run. The for loop starts with 4, of course, and we have to define an internal variable, and we have to define an initial value when the loop starts, and we have to define the end value until the loop runs. So the internal value will be n variable, and this starts from 0 to number of the column. So this will be this loop will run until the n internal value is equal with the number of the column. The value is increased with 1 in each loop, of course. For loop must be closed with end, and if you closed and type correctly, you can see the whole loop is highlighted and moved. The code is moved a bit to make transparent and understandable the code. Okay, and now I modified a bit the origin to the new variables. And I add an extra line to the code which will be modified the origin of the new columns in each loop with the given distance. Okay, so let's run the code, and here you can see 5 columns is created with 3000 millimeter distance between of it, and with the given parameters. And also we can modify not just the number of the column but the height of the table member, for example, in each loop. So if we give a new auxiliary parameters. So for example, I modify now the height of the tapered member at the endpoint of the structural member. And each loop I increase the height at the endpoint of the structural member with 50 millimeters. Okay, let's run again the code. So here you can see the end height of the column is increased with 50 millimeter. Okay. And we can use subcycles also. For example, we can create numerous columns, not just in the x direction, but in the y direction also with subcycles. For this, I define a variable to the number of the columns in not just the x direction, but in the y direction. So for example, 3 columns in the y direction. And I modify the code a bit. And let's start with the 4. The internal variable is the m, start from 0 to the number of the columns in the y direction. And if we have to close with end. And I modify the origin coordinates in the y direction in each loop with the column distance. Okay, I hope everything is correct. And if you run again the code, here you can see the columns created not just in the x direction but in the y direction with these subcycles. Okay. And we can make branching also in the code, so we can use if-else statement for this. For example, in csPI, if statement contains a logical condition which can be true or false. If the condition is true, then the first code after the if will be executed. If it's false, then the second code after the else will be executed. For example, I would like to apply different tapered height depend on the column height, and for this I will use the if-else statement. So I go back to the variables of the tapered member and I create a new variables which will be another, for example it is 2000 millimeter. This will be another option. And here So the if is start with if, of course, and followed by the logical condition. So if the column height, which is h0, the variables, is less than, it's less than or equal with 400 millimeters, the height of the structural members will be equal with this variable. But if it's not true, so the column height is bigger than 4000 millimeter, let's apply not this variable but the next one, and the if-else statement must be closed with and if. And if it's correct, you can see it's again highlighted with blue. Okay. Let's run again the code. I hope it's correct. So here you can see, so because the column height is less than 400 millimeters, 4000 millimeters, because it is 3000 millimeters, the csPI code uses this end height for the tapered members. But if I modified the column height, for example, to 500 millimeters, and execute run again the code, you can see the end height of the tapered member is 2000 millimeters. Okay, so I'm done with my short presentation. So in this webinar, I would like to just show you a small example. So what can you create in csPI, and how can you use the different commands, the parameters, how can you create variables and use for loops and if-else statements. So please learn the wiki page of csPI. You can find all of the commands and all of the parameters, and if you click, for example, on to the structural plate command, you can find all of the variables. At the end of each of the commands or object types, you can find a short example with what can you use with a simple Ctrl+C and Ctrl+V, and you can add to anywhere to the command. And if you run again the code, you can see the plate, the structural plate is created according to the parameters. So you can use this sample code to try or learn how csPI is working. And now I would like to show you a real example. How can you use csPI in a real project? So for this, I open a new model. So if you click on the folder button, we can open previously created csPI codes. For example, I have a 3D tapered hole with purlins and bracings. So this code is a complete 3D hole with tapered frames and purlins, and it is fully parameterized. So here you can see, so the code starts with the parameters. So the first is the span. The next parameter is the origin of the placement. The next parameter is the frames distance. So in this case it is 6000 millimeter, followed by the column height variables, the top height, the apex height of the frame. So you can see the next parameter is the number of the frames, and followed by the tapered members parameters, the beam start height, beam end height, column start height, column end height, and after that you can find the model build parts of the code, and here you can see all of the object creation codes. So let's try this code. If you click on this play button, here you can see a full 3D hole is created with these parameters. Not just the structural members, but the load transfer surface is created. And if you go to the loads tab, we can see two simple load case and load groups is created, a permanent and the temporary, and then the impose load group is created. And if you see the load cases, you can see some point loads are were assigned to this load case. And if you go to the live load case, we can see a surface load is applied on the top of the roof. And if you see the details of the hole, you can see that the frame is created from tapered members. The purlins are placed with some eccentricities, is connected with link elements. If you see the connection element parameters, here you can see not just the connection is placed in the right place, but the release is set and the position of the connection also set. And if you modified any parameters of it, for example, the span from 20,000 millimeters to 30,000 millimeters, and I moved a bit in the x direction, for example, 4,000 millimeters, and the frame distance I modified from 7,000 millimeters. The column height, let's modify to 5,000 millimeters, and the top height to 8,000 millimeters, the number of the frames from 8 to 10. And for example, I modified a bit the column, the tapered column member. The end height will be 1,000 millimeters. The start point height will be 3,000 millimeters. And if I run again the code, you can see that the new 3D hole is created with the modifying parameters, with all of the complete, it is a complete model, so you can, all of the structural members, the bracings, purlins, load transfer surface, and the loads, of course, is created accordingly. So I think this is a very unique and very useful tool. If you are dealing with standardized structures, so you have to create just simple csPI code, and you can run and modify the parameters in any time. And you can create your different model, or you can create your a bit modified model in a very short time. Okay, for now I'm really done with my presentation. So the last screen is about some informations about ConSteel. So on the ConSteel website, so our main information field is the ConSteel website, where you can find some news about ConSteels. You can find the upcoming webinars and events. You can follow us on our social media sites, which are mainly up to date. So all of the all of the videos, blog posts, news are posted on Facebook and LinkedIn. And of course, we have a YouTube channel where you can find all of the videos about ConSteels. Of course, this webinar record will be posted on our YouTube channels. You can find all of the previous webinars records on the YouTube channels and some other extra videos about the new functions. We have a blog where you can find some useful tips and tricks about ConSteels. You can find some frequently asked questions answered on it. And of course, we have two email address. The first one is the info@consteelsoftware.com is the main email. But if you have some questions, technical or engineer questions, or any other support questions about ConSteel or CRJoin, please send to the support at consteel.atlassian.net. It is a customer service system. In this system, a ticket is created if you send the new support questions, and you can see and we can follow your questions, and we can answer your questions through it. And of course, we have a phone number, so if you would like to chat with us or talk with us, you can use the phone, of course. I would like to thank you everyone to attending on our today webinar. I hope you enjoy and learn in this presentation, and see you on our next webinar. So thank you very much, and goodbye.